Hi everyone, this is a team of Abelana VR, and we want to show you the educational experience, the multi-user educational experience that we have been working on during the past several months. So let's dive into it. So, as you can see, this is a multi-user setting organized in the form of a virtual classroom that we're designing specifically with an idea of virtual reality venues, virtual reality arcades in mind, hoping to foster your cooperation with local schools, education centers, summer camps, bringing groups of kids into your venues and organizing an educational experience for them. Now, we have already organized several in-VR sessions for many of you, and thank you to all of those who participated. Thank you very much for all the contribution that you have made in the form of advice, recommendations, and ideas that we're trying to implement as many of them as possible right now. For those of you who didn't have a chance to participate in this experience, we wanted to record this quick outline of what is in development. Keep in mind that this is still very much a work in progress, but we think that it will at least give you an idea of where it is all going. So the setting of the experience reminds like a typical setting that we use in our multi-user scenarios. So it starts with an amphitheater type of a layout to which kids log in from various Vives in the experience is developed for the Vive system, and kids together with their teacher can participate in the experience. So kids will be logging in and sitting in these cockpits in the form of the avatars, and in the base scenario of the experience there is a teacher who also uses one of the devices, one of the head-mounted displays, to log into experience and to lead it. The experience can be run also without a teacher, or a teacher can use a specially designed mobile app to control the flow of the experience and communicate with people who are in VR. In a standard setting, when the teacher is in the experience in the form of a presenter, he can communicate with kids. Kids can raise questions. They have a question mark button in their cockpits when they want to ask something. The teacher activates them this way. Boom. And when somebody is activated, there is a beam of light, and then the voice of this person can be heard by everyone, including a teacher. Otherwise, everybody is muted to avoid, a lot of background noise coming from the device. So as you can see, this particular virtual classroom is dedicated to the topic of atoms, orbitals, periodic table, basically the main foundation of what people study on their chemistry lessons. The experience is designed for the grades from 7 to 12, and of course the knowledge base of kids in the 7th and 12th grades is pretty different. So we try to create the experience in a flexible way where presenter and you guys can focus on different parts, making either a little bit more entertaining or a little bit more hardcore, more like actual chemistry class. So when the teacher is presenting this, as I've said, everything that the teacher does with the periodic table is repeated on the screen behind him. And of course, kids don't come to VR centers to read, so a lot of this information is more like a background information. If a teacher or presenter wants to spend a little bit more time talking about iron, for example, or vanadium, so they can open this information and, of course, spend some time explaining to the kids what is periodic table, why is it periodic, how do you slice and dice it, different groups and big groups and subgroups of elements, all the columns of elements, what are commonalities between them, but also periodic table itself has a lot of ways how you can present it, slice it by the types of orbitals, by going into the orbitals, into orbital structures of elements. Kids can see, they can activate each particular orbitals, and they see these orbitals as a kind of a mini version in their cockpits. The same orbitals are kind of repeated as supersized models on top of the presenter, but also every kid, every participant can do the same kind of actions in their cockpits. And the last way to present the table is basically, countries, which country opened which elements. So we thought it was also be a nice addition to how you can look at the periodic table. So we expect that a teacher will spend somewhere between 2 and 5 minutes talking about the periodic table. This is not the main reason for the experience, but it kind of provides a background information about various kinds of elements and how they are organized. Then we're going to the main part of the experience where kids and a teacher can create those elements in an atom maker. Here, all the kids, all the participants are placed in a arena type of a position when everybody sees a presenter and what this presenter is doing, but at the same time they have a good overview of other students, other kids, playing in this experience, participating in this experience. So the first setting in this arena layout is basically a set of tools which a presenter can use to create an atom. And they can probably start with something simpler. Let's go with just oxygen. And what we get in front of us are, all those tools and some of the charts and tables that kids learn in their schools anyway. So they will see a certain level of familiarity with the material that they see in the curriculum. Once again, the goal of what we're doing is not to replicate curriculum, is not to give to the kids once again what they have already started, but rather to use VR where its strength is the most, and visualize those concepts which are particularly difficult to understand using like a standard two-dimensional means of communication like images or even videos. We all know that VR is perfect with this kind of an information where when you need to visualize things and make understanding faster and intuitive through visualization and interactivity. So we are in an atom maker, and on the right hand side we have this zoom, which allows us to go through various energy levels of a potential atom. And on each energy level, there are all kinds of different orbitals that are available as P, D, and F orbitals. Kids need to use these orbitals and activate those orbitals to create an element. So we have picked an oxygen, and here's a little helper says, and by the way, everything that I'm doing is replicated in a supersized version on top of me so that everybody can see it. So there are 8 protons that we need to add into the nucleus of oxygen. 8 protons because there is this 8 atomic number of an element. We start putting protons. Here's a counter. We put 8 protons. Let's add one more. 9 protons. Oops, we did too many. And we have the remove tool, which is basically a vacuum cleaner. It sucks, particles in. Then we go back to 8. Next, we need to add neutrons to the nucleus, right? And how many neutrons? So we give you a formula for that. We take the atomic weight, we subtract the atomic number, and we get an average number of neutrons in this particular version of oxygen that we are creating. So we're adding 8 neutrons, and you see protons and neutrons, once you add them, they start clumping together, creating the actual nucleus. Then we go to the next energy level, the first energy level, the s orbital, and we are adding 2 electrons maximum per each orbital, the way we know it from the chemistry lessons in school. So here we add 2 s electrons on top of on top of our atom maker. We see this formula that kids are being taught in school. It basically describes to them how many electrons they put on which orbitals. So we put 2 electrons in the first energy level on an s orbital. On the second energy level, we have an s orbital, but we also have 3 different p orbitals positioned differently in space. And we need to understand how many electrons we add to each orbital. Here we have 2s2, which means 2 electrons for the s orbital, and then we need to add 4 electrons for the p orbitals. And if the kids started well in school, they know that the way they feel it, they have to add 1 electron to one orbital, 1 electron to another orbital, and 1 electron to the third orbital, and the fourth orbital goes to one more orbital, which means instead of putting 2 electrons on 2 orbitals, we actually need to fill 3 orbitals with 1 electron and add 1 more electron to one of the orbitals. So this way we have created oxygen, but you know what? Let's make a mistake and let's remove one of the electrons. For example, we forgot to add an electron on one of the orbitals. But we think that we have created oxygen and we're pressing the commit button and it doesn't work out. It gives us a mistake. It shows where exactly the mistake is. And kids can go to either click here or click here. They will go to the orbital which is missing something, and this will kind of draw their attention to where the mistake is. So they'll try to add an electron and they probably correct it. Let's press commit, boom, and we have a depiction of an atom in front of them. Now, of course, the same thing can be done with much more complex elements. Let's pick something ridiculously heavy. I'm not going to be filling all of those, 75 protons and going through this formula. Once kids learn the mechanics of, filling all of those elements, once it becomes relatively straightforward to them, and on our tests, we see that, kids pick this stuff very fast. At least the high school kids move to more advanced atoms really quickly. Like the second atom they're creating is already something that takes 2 lines, right, of description. With the 7th and 8th grades, maybe they're not going to go that far unless they want to spend some time learning it and experimenting with it. But kids from younger grades, they can still click through various orbitals and available, see all those interesting shapes and forms, and this experience is meant to inspire them to research more, to experiment more, to try actually go ahead and create those atoms. So as I have said, the main goal of this experience is to give a better intuitive 3-dimensional understanding of what the atom consists of and which orbitals are available where. Putting descriptions of all of these orbitals on paper as images is close to impossible for kids to understand in a proper way. And we believe that with this fast advancing science nowadays, VR brings a very good tool to make understanding of concepts much faster and much more intuitive, especially for the school level. Now, next, after this sandbox experience where kids experiment with different atoms and orbitals, they have 3 games that they can engage with after they understood the mechanics of interaction with everything around them. The first 2 games are a little bit more educational, and they are really grounded in what you see right now around you. So the first game, once you go to this first game, it's basically a game where all the kids participating in the experience, they are creating an element in a kind of a race, to try to see who is going to be the first one to create an element. A teacher can select this element, again, either from the VR experience or from a mobile app, and the selection could be random or manual. Let's just click random selection, and the system basically randomly chooses one element, and we get a particularly heavy one. So the kids will probably spend some time assembling this element, and once they click start button, everybody starts assembling an element. I'm not going to be going through it right now because for this we would need like a classroom of kids to appreciate, the dynamics of this orders, but you understand the idea. The first game is basically to see who are the first 3 kids to assemble a particular element, or the busters in assembling a particular element. The second game, it's kind of based on the same sandbox experience, but it is a little bit more complicated. Teacher selects duration of the game, from 3 minutes all the way to 10 minutes, but probably most of the teachers will be choosing 3, 4, 5 minutes. From our tests, we see that 3 minutes is pretty good time for that. But maybe when you go for more competitive scenarios, you want to give them a little bit more time, like up to 5 minutes. It takes time to create heavier elements, and once kids understand the mechanics and the dynamics of the experience, they tend to go for heavier elements to create. Now, having said that, we had experiences when the kids who were participating in our tests, they some of the high school kids who were playing against younger grades, and the high school kids, they went for like heavier elements, trying to win a game. I have to step back. I didn't tell you, what the game is. So a teacher selects duration of the game, and within this time frame, kids need to create groups of elements with a heavier atomic mass. So they can go either for 5 hydrogens or heliums, or they can pick like 1 iron, or going all the way to plutonium, and win the race by assembling a heavier element if they feel confident they will have enough time. So what I was telling to you is that some of the kids from the high school who were kind of ambitious enough and picked heavier elements to create eventually lost this race, because within the given number of minutes, younger kids who focused on simpler elements, they created some elements. Let it be like just few like heliums, but within that time, the high school kids didn't have enough time to finish what they were doing, and thus they lost the race. So the game itself gives a very nice dynamics in which kids of various age groups can participate, and it stays a learning type of an experience. And I'm not even talking about the situations when some elements become a little bit trickier, and where you logically assume that somewhere in the middle of the orbitals, there should be an electron. Suddenly, this electron is missing, and instead you have 2 electrons on the the last orbital. And it takes a while for kids to figure out where and why this mistake is once you go down the periodic table. So in general, it becomes a nice combination between a gaming experience and an educational experience, and it can bring educational value to kids of various ages. The last game is a pure fun, and it's basically a combination of our chemistry experience. When I started, there will be a river of atoms from the previous experience that kids already created. There will be a river of these atoms, and kids are sitting in a circle position on a big rooftop. So it's a combination of the classroom experience, but also with the weird additions of probably Angry Birds and Rich's Planck experience. The ground that you see under the cockpits, it is going to be transparent, and kids basically will see a very high-rise. They're standing on the rooftop of a high-rise tower. They're basically they're catching these atoms, and they're shooting each other. Let me shoot something smaller so it won't fly away right away. They're shooting each other from the catapults with an idea to push the other, team members off the rooftop, and whoever stays the last basically wins. Let me take something heavier like this element, and it should cause more damage. We need a little bit more. Oh yeah, it actually fell off. Again, as kids pull the atoms to themselves, in their cockpits, they have special menu that shows information about which exactly element they have caught, and giving them an idea of how much damage these elements will cause them. hopefully, eventually, an experience like this can be provided to the entire class of kids, starting from as low as 3, 4, 5 kids, going all the way to 30 plus kids, with an option of teacher participating in the experience or not, and with an option of other kids who are not an experience but who are waiting for their turn, using a mobile app to actually influence the gameplay, especially this gameplay where the atoms floating around. The kids who are sitting and not in the VR, they will have a mobile app to generate atoms and give it to friends of theirs in this game, or just to everybody in the river. This way, affecting the outcome of the game. Uh, this experience is still very much in production. We hope to finish it within a matter of weeks, month maybe, and then start field testing it with you guys and showing to a bigger number of schools, education centers, summer camps, and everybody else that VR centers, VR arcades, VR venues can be really good providers of educational experience for groups of people, and those educational experience could be easily modified from a more hardcore academic ones to a lighter gaming experiences, but still with an educational element. Hope you will like it.